Hey guys, tonight we're going to step into a different kind of darkness, a quiet that isn't born of night, but of distance. Imagine you're drifting weightless in the cold void of space, and ahead of you, a familiar blue marble. Our Earth is not a world of its own, but a tiny fragile moon in the shadow of a colossal gas giant. You can see the swirls of our oceans and the gentle curves of our continents, but they are lit by a sun so far away it's just a brilliant, unblinking star in a perpetual twilight. Jupiter, our new lord of the sky, looms in the frame, its great red eye, a constant, terrifying beacon. This isn't a story of survival because, let's be honest, you'd probably be a tiny frozen smear of stardust pretty quickly. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And if you're up for it, let me know where you're listening from and what time it is for you. It's a small way to connect, to remind ourselves that we're all under the same sky, even if tonight's sky is a little different. Now, lean back, close your eyes, and let's begin our journey. Our story begins not with a bang, but with a silent shift, a slow, gentle relocation of our entire world. It's a journey we didn't ask for, a cosmic rezoning that placed us in an orbit we were never meant to inhabit. Our Earth, a planet so proud of its independence, is now just another satellite in Jupiter's vast swirling court. The first thing you'd notice is the light, or rather, the lack of it. The sun, a warm and life-giving presence for billions of years, is now just a distant, intensely bright point. Its rays are no longer a comforting warmth, but a faint, almost theoretical illumination. We're talking about a level of light so diminished that noon on Earth feels like a moonlit midnight in our old reality. This new twilight world is a place of profound cold, a realm where liquid water on the surface would be a fleeting memory instantly frozen into an icy shell. The atmosphere, once a complex mixture of gases and water vapor, would begin to thin, the water freezing out and falling as a soft, continuous snow. This isn't the kind of snow we know, but a fine crystalline dust that settles silently, layer upon layer, until our vibrant blue world is wrapped in a pristine white shroud. It's a blanket of frozen history, each flake a testament to the old warmth we've lost. The sky, though, is where the true spectacle unfolds. Where once there was a lone moon to guide the night, we now have a celestial pantheon. Jupiter, a colossal and striped behemoth, dominates everything. It is a presence so massive that it fills a significant portion of our sky, a constant reminder of our new place in the cosmic hierarchy. The sheer scale of it is difficult to grasp. If you were to stand on our new Earth and look up, Jupiter wouldn't just be an object in the sky. It would be the sky itself. Its swirling banded clouds would be a tapestry of reds, browns, and whites, constantly shifting and turning in a slow, majestic dance. This is where we touch upon a fascinating scientific concept, the nature of gravity. We often think of gravity as a simple downward pull, the force that keeps our feet on the ground. But in a more profound sense, gravity is the very fabric of space-time, a curvature in the universe caused by the presence of mass. Einstein's theory of general relativity, a cornerstone of modern physics, describes this phenomenon in elegant mathematical terms, but the simplest way to think about it is to imagine a bowling ball placed on a stretched rubber sheet. The ball creates a dent, and any marbles rolling nearby will be drawn into that depression. In our new reality, Jupiter is the bowling ball, and our Earth is a marble trapped in its immense gravitational well. This is not just a pull, but a bending of the very geometry of our existence. This new gravitational master has some profound and immediate consequences for us. The most dramatic of these would be the tides. On our old Earth, the moon was the primary driver of our ocean tides, and the sun a secondary influence. But now, with Jupiter as our nearest celestial neighbor, those tidal forces would be amplified to an unimaginable degree. We're not talking about a gentle ebb and flow. We're talking about ocean levels rising and falling by hundreds of meters. Imagine a world where the continents are not solid ground, but temporary islands in a sea that is constantly violently in motion. Coastal cities would be non-existent, and the very shape of our landmasses would be under constant assault. The geological effects would be just as staggering. This immense tidal stress would cause a continuous rumbling beneath our feet, a ceaseless bombardment of earthquakes and volcanic activity. The solid crust of our planet would be stretched and pulled like a piece of dough, constantly being kneaded by Jupiter's gravitational hands. This leads us to a strange, almost unsettling scientific fact. Jupiter's moon, Io, the most volcanically active body in our solar system, is a prime example of this phenomenon. It's a moon that is constantly being squeezed and released by Jupiter's gravity, and this tidal friction generates so much internal heat that its surface is a constant landscape of fire and molten rock. In our new home, we would be a larger, colder, and potentially more destructive version of Io. And what of the Great Red Spot, that terrifying eye staring down at us? The Great Red Spot is a persistent, high-pressure storm larger than Earth itself that has been raging for at least 350 years. It's a storm of such immense power and scale that it defies our terrestrial understanding of weather. In our old world, a hurricane is a temporary inconvenience. On our new Earth, this storm is a permanent swirling presence in the sky, a cosmic scar that serves as a constant silent reminder of Jupiter's power. It's an interesting thought that on this new Earth, our very concept of weather would be completely rewritten. With the sun a distant memory, the primary source of our atmospheric energy would no longer be solar radiation. Instead, it would be the immense tidal forces and the constant bombardment of charged particles from Jupiter's magnetosphere. This is where we get into another core concept, the magnetosphere. Every planet with a molten core generates a magnetic field. On Earth, this field protects us from harmful solar radiation, creating a kind of shield. Jupiter's magnetic field is 1,000 times stronger than our own, a vast, complex web of charged particles that extends millions of kilometers into space. Our new Earth, now a tiny speck within this field, would be a constant recipient of a cosmic light show. The aurora borealis, a rare and beautiful spectacle on our old Earth, would be a permanent fixture in our new sky, a shimmering curtain of light that would paint the darkness with brilliant hues of green, red, and blue. The silent mystery in all of this is what happens to life. We're so used to life being a function of sunlight, of photosynthesis, of a delicate balance forged over billions of years. But in this new reality, that balance is shattered. What happens to the deep-sea creatures, the ones who already live in a world without light? Do they thrive their existence, a testament to the resilience of life in the face of impossible odds? Or do they, too, succumb to the new violent pressures of a constantly shifting crust? This raises an interesting question. Is life a product of its environment, a predictable outcome of specific conditions? Or is it a stubborn, almost magical force that finds a way to exist, no matter the circumstances? The truth is, we don't really know for sure. This is where science gives way to a kind of quiet philosophical wonder. The more we learn about the universe, the more we realize how little we truly understand. We look at the planets and moons in our own solar system and see possibilities we never imagined. The icy moon Europa, another of Jupiter's moons, is believed to have a vast subsurface ocean of liquid water kept warm by the same tidal heating we've just discussed. Could life exist there, a form of life that has never known the light of the sun, a life that is a product of pure, unadulterated geothermal energy? The prospect is both humbling and thrilling. It reminds us that our own version of life, the one we've known for so long, may just be a single fragile note in a symphony we can't even begin to comprehend. So we find ourselves in this new alien reality, a world of perpetual twilight, violent tides, and a sky dominated by a colossal banded giant. We are a moon now, and with that comes a new set of rules, a new rhythm to our existence. The old sun is a memory, a warm whisper on the wind, and the new sun, Jupiter, is a cold, powerful presence that demands our obedience. The world is a canvas of perpetual change, with the land and sea in a constant state of flux, and the sky a kaleidoscope of color and light. This is not the Earth we know, but it is still Earth. It's a planet that has been fundamentally violently reshaped, but it carries with it the ghosts of its past and the promise of a strange and unknown future. We are observers, peering through the lens of science and imagination, trying to make sense of a world that is at once familiar and utterly alien. We are looking at our home and asking, what if? What if we were just a moon? A lonely speck of blue and white dancing in the shadow of a giant. Our celestial dance partner, Jupiter, isn't just a passive presence in the sky. Its immense gravity pulls at our planet with a constant unyielding force, a slow and majestic dance of celestial giants. It's a cosmic waltz where Earth, once a solitary dancer, is now swept up in a powerful embrace. This relationship, this gravitational lock, is the very heartbeat of our new existence. We see it in the way our orbit is no longer a gentle near-perfect circle around the sun. Instead, we're tracing a complex swirling path, a kind of planetary jitterbug around both Jupiter and the distant sun. It's a dance dictated by a principle so fundamental to our universe, it's almost taken for granted every object with mass exerts a gravitational pull on every other object. But with Jupiter, that pull is so overwhelmingly dominant that it warps our very sense of direction and stability. It's a reminder that we are not the masters of our fate. We are simply a part of a much larger, more powerful system. This new locked-in orbit has a profound effect on our planet's rotation. On our old Earth, a day was defined by the time it took for our planet to spin once on its axis. But in this new reality, that rotation is no longer a simple, predictable motion. It's now heavily influenced by Jupiter's tidal forces. These forces would act like a powerful brake, slowing our planet's spin over time. This leads to a fascinating scientific concept known as tidal locking. Tidal locking is what happened to our own moon. Its rotation slowed over billions of years until its rotational period matched its orbital period, leaving one side of the moon permanently facing Earth. In our new hypothetical world, a similar process would begin for us, but with a massive twist. Jupiter is so powerful that our rotation would slow dramatically, potentially leading to a much longer day than we've ever known. It's a process that unfolds over vast timescales, but the effects would be noticeable even in the short term. The old familiar rhythm of 24 hours would be a distant memory. A new day would emerge, a day of immense, sunless twilight, where the sky is dominated by the swirling bands of our new master. It's a concept that challenges our very notion of time and its passage. The tidal forces, the relentless kneading of our planet, would be a constant source of geologic activity. We spoke of earthquakes and volcanic eruptions, but let's delve deeper into what this might actually look and feel like. Imagine the solid crust of our planet as a thin, brittle skin stretched over a boiling molten interior. Jupiter's gravity would be pulling on this skin with such force that it would be in a constant state of flex and strain. This would be a continuous low-level tremor, a permanent vibration that would be felt deep in the bones of the Earth. We're not talking about a sudden catastrophic event, but a kind of background noise, a constant rumbling that would be a part of the world's new song. This would have a bizarre and beautiful consequence. The constant internal heating would lead to an incredible increase in geothermal activity. Beneath the frozen surface, a network of hot springs and geysers would emerge, creating pockets of warmth in a world of otherwise crushing cold. Life, which we'll talk about later, might find a foothold in these isolated, geothermally active zones. It's a paradoxical situation. The forces that would make the surface uninhabitable would also provide the very energy needed for life to survive beneath it. This brings us to a peculiar scientific oddity, one that speaks to the unexpected ways our universe works. the principle of conservation of angular momentum, states that an object's rotational speed stays the same unless an external force acts on it. When a figure skater pulls their arms in, they spin faster. When they push them out, they slow down. In our case, Jupiter's gravity is that external force, and it is relentlessly pulling on our planet, stealing a tiny amount of our rotational energy and adding it to Jupiter's orbital energy. The two bodies are in a constant exchange, a silent negotiation of energy across the vast gulf of space. This is a subtle but profound concept, and it speaks to the interconnectedness of everything in the cosmos. Our planet, once a self-contained system, is now inextricably linked to the fortunes of another far larger world. It's a kind of cosmic symbiosis, a shared existence that alters the fundamental physics of both bodies. In this new dance, we'd also have to contend with a new understanding of weight. The gravity on our planet would be a complex shifting force. While our own gravity would still be the primary force pulling us to the surface, Jupiter's immense pull would create a secondary directional force. Imagine standing on a beach with the moon directly overhead and feeling a slight difference in your weight. Now, multiply that feeling 1,000,000 times over. When Jupiter is directly overhead, its immense gravity would lighten our perceived weight. But as our planet rotates and Jupiter moves to our side, that force would pull us sideways. The experience of gravity would no longer be a simple downward pull. It would be a complex multidirectional force that changes with every turn of our planet. This is a subtle yet profound shift in our relationship with the world, a constant reminder that we are no longer alone in the cosmos. And what of the mystery of this dance? This raises an interesting philosophical question. Are the orbits of planets, the gravitational ballet of the cosmos, truly deterministic? Can we, with enough computing power, predict the future of every celestial body with absolute certainty? Or are there subtle chaotic influences at play, a cosmic butterfly effect, where a tiny change in one part of the system can have immense unpredictable consequences elsewhere? The truth is, we don't really know for sure. The three-body problem in physics, which involves predicting the motions of three mutually interacting bodies, is famously complex and often has no general solution. In our new system with Earth, Jupiter, and the Sun all interacting, the problem becomes even more intricate. We've introduced a kind of beautiful, unknowable chaos into our existence. The universe, it seems, is not always a perfectly choreographed ballet. Sometimes, it's a swirling, unpredictable mosh pit of celestial bodies, a chaotic dance where the steps are made up as they go along. This brings us to a final, more poetic reflection on this new orbital dynamic. We are no longer a world with a single defining axis. We are a world with multiple masters, multiple gravitational pulls that shape our very existence. The old rhythm of day and night, of seasons and tides, is gone. In its place is a new, stranger rhythm, a beat dictated by the colossal presence of Jupiter. We are no longer a solitary world spinning serenely in the void. We are a satellite, a companion, a tiny blue marble in a grand and terrifying cosmic court. It's a humbling thought, a reminder that our existence is fragile and our place in the universe is not guaranteed. We're an experiment, a beautiful and terrifying thought experiment in what it means to be a moon. We've traded the quiet independence of our old life for the dramatic, powerful, and utterly chaotic embrace of a new one. It's a trade that has reshaped our very essence, and in the grand scheme of things, perhaps that's not such a bad thing after all. To be part of something so vast, so powerful, even if it's terrifying, is to be a part of the universe's grandest story. The most dramatic consequence of our new dance with Jupiter is the immense tidal breath of a new world. We touched upon this before, but it's a force so profound it deserves a deeper look. On our old Earth, the gentle rise and fall of the tides were a quiet, predictable rhythm. But here, with Jupiter looming so large, that rhythm is a violent, planet-shaping pulse. It's a force that would make our old tides seem like a whisper against a tempest. Imagine a world where the oceans are not a stable body of water, but a vast, churning mass, a liquid skin being stretched and squeezed by an unseen hand. The tides would not just lap at the shores, they would tear at the continents. We're talking about an extreme tidal range with water levels rising and falling by hundreds, even thousands of feet. This is not just a change in the waterline, it is a fundamental reshaping of our planetary surface. This tidal flexing, this immense power, would have a massive effect on our planet's geology. The friction generated by this constant squeezing would produce an incredible amount of internal heat. We see a smaller scale version of this on Jupiter's moon Io. The heat from tidal forces makes Io a volcanic hellscape, a testament to the immense power of gravity. Our new Earth, being much larger and more geologically diverse, would experience this heating in a different way. The crust of our planet, once a relatively stable shell, would become a fractured and active surface. This wouldn't just be a few new volcanoes. It would be a complete overhaul of our planet's tectonic activity. The old fault lines would become hyperactive, and new ones would tear across the continents. We would be living on a world in a constant state of geologic rebirth, a planet where the ground beneath our feet is never truly still. The sound of our world would be one of perpetual rumbling, a deep resonating hum from the molten heart of our planet. This new tidal reality would also affect our atmosphere. We often think of tides as a phenomenon of the oceans, but they exist in the air too. The atmosphere of our old Earth experienced a very slight tidal bulge, but with Jupiter's immense gravity, that bulge would become a significant part of our weather system. The air, like the oceans, would be in a constant state of flux pulled and stretched by Jupiter's gravitational hand. This would create powerful planet-wide winds and atmospheric waves. We're not talking about a simple breeze. We're talking about a permanent global gale, a constant whisper of Jupiter's influence. This atmospheric upheaval, combined with the new distant sun, would create weather patterns that would be completely alien to us. The aurorae we discussed would be a constant shimmering veil, but beneath it, the air would be in a perpetual state of violent, chaotic motion. This brings us to a peculiar scientific paradox, the concept of tidal heating. It's a process that both destroys and creates. The immense heat from tidal friction would make the surface uninhabitable, but it would also create a potential refuge for life. Beneath the planet's crust in the deep ocean, the geothermal vents we spoke of would be a constant source of warmth and energy. These deep-sea vents, known as black smokers, are rich with chemical nutrients that can support entire ecosystems without any help from the sun. On our old Earth, life in these vents is a curious anomaly, but on our new Earth, it might be the only life left. These deep-sea communities, a complex web of microbes, tube worms, and strange crustaceans, would be living in a constant warm embrace, shielded from the cold and chaos of the surface. It's a beautiful thought, a testament to the resilience of life. Even in the face of a cataclysmic shift, life finds a way. The mystery in all of this is what happens to the core of our planet. Our planet's molten iron core is what gives us our protective magnetic field. But with this constant, immense tidal stress, would the core's churning motion be affected? Could this new tidal reality slow the core's rotation, weakening our magnetic field? Or could the tidal friction heat the core even more, creating a more powerful field? The truth is, we don't really know for sure. The internal workings of a planet are a complex, mysterious system. It's a silent, hidden drama, a slow dance of metal and heat that we can only glimpse from afar. This raises a fascinating question. Is a planet's fate sealed by its initial conditions? Or can a new powerful influence fundamentally change its destiny? It's a question that reminds us of the beautiful, unknowable chaos of the universe. And so our world breathes. It breathes with the immense rhythmic force of Jupiter's gravity. It is a breath that reshapes the continents, churns the oceans, and fills the air with a constant humming motion. We are a planet in a perpetual state of tidal flux, a world that is never truly still. The old familiar rhythms of our world are gone, replaced by a new, more powerful beat. It's a terrifying and beautiful thing, a testament to the fact that even a planet can be a living, breathing entity. We are not just a rock in space. We are a partner in a grand cosmic dance, and the steps we take are dictated by the immense presence of our new master. We are a world in the process of being born again, a world shaped by the tidal breath of a giant. With Jupiter as our new celestial parent, the very air we breathe and the sky we see would be completely remade. We're used to weather being a product of solar energy, the sun heating our atmosphere unevenly, creating high and low pressure systems that manifest as winds, rain, and snow. But in this new twilight world, that old engine of weather is nearly silent. Instead, our atmospheric dynamics would be forged in the giant's shadow, driven by forces far more powerful and strange. The most striking of these would be the constant planet-wide aurorae, a perpetual light show born of Jupiter's immense magnetosphere. This is a phenomenon that touches on a core concept of physics, electromagnetism. We often think of magnets as simple objects, but a magnetic field is a powerful force that can guide and accelerate charged particles. Jupiter's field is so vast and so strong that it traps an enormous amount of plasma and high-energy particles from the solar wind, creating a kind of cosmic blender. Our new Earth would be right in the middle of this maelstrom, constantly bombarded by these particles. When they hit our upper atmosphere, they would excite the gases there, oxygen, nitrogen, and others, causing them to glow. The result would be a shimmering, iridescent veil of light that would cover our entire sky, a permanent aurora that paints the darkness with ethereal color. This constant bombardment of charged particles, though beautiful, would also have a profound and dangerous effect on our world. We're talking about a level of radiation that would make the surface uninhabitable for most life as we know it. Our old Earth's magnetic field, though 1,000 times weaker, was our planet's primary shield against this kind of cosmic assault. But now, with our planet nestled within Jupiter's much stronger, but also much more turbulent magnetosphere, we would be subject to a constant stream of high-energy radiation. This is a fascinating scientific fact. Jupiter's magnetosphere is so vast that if we could see it, it would appear larger in the sky than the moon. It is a cosmic weather system in its own right, with its own storms and currents of charged particles. Our planet, as it orbits, would be like a tiny boat, sailing through this immense invisible ocean of plasma, constantly being buffeted by its currents. Any life on the surface would have to find a way to adapt to this extreme environment, perhaps by developing new forms of protection, or more likely, by retreating to the safety of the deep oceans or underground. The weather systems in our atmosphere would be shaped not just by the particles from Jupiter, but also by its immense gravitational pull. We talked about atmospheric tides, but let's consider the sheer scale of the phenomenon. These tidal forces would create massive globe-spanning atmospheric waves, a kind of permanent pressure system that would circle the planet. These waves would interact with the planet's rotation and any remaining solar heating, creating monstrous, unpredictable storms. We're not talking about hurricanes that last a few days. We're talking about storms that could last for months, if not years. These storms would be unlike anything we've ever seen, with winds of unimaginable speed and a constant interplay of electrical discharges caused by the charged particles from Jupiter. It would be a violent, beautiful, and terrifying world where the very air is a constant source of wonder and danger. This raises a deep philosophical question about the nature of order and chaos. In our old reality, weather systems, though often unpredictable, still followed a certain logic, a set of rules governed by the laws of thermodynamics and fluid dynamics. But in this new world, with so many powerful competing forces at play, the distant sun, Jupiter's gravity, its immense magnetosphere, and the internal heat of our planet, the system becomes so complex that it's almost impossible to predict. The weather would be a kind of beautiful, unknowable chaos, a permanent mystery that we could only observe, not understand. This reminds us of a concept from chaos theory, the butterfly effect, where a tiny change in one part of a system can have immense unpredictable consequences elsewhere. In our new reality, the smallest change in Jupiter's magnetosphere or the slightest shift in our orbit could unleash a cascade of atmospheric violence, a weather system that defies all our old rules. The mystery in all of this is what happens to our atmosphere over the long term. Jupiter's magnetosphere, while it offers a kind of shield, is also a source of constant bombardment, a cosmic sandblaster that could slowly, inexorably strip away our planet's atmosphere. This is a subtle and slow process, but over millions of years, the atmosphere that protects us could simply be eroded away. This raises a fascinating and somewhat unsettling question. Does our new celestial parent, the one that creates such beauty in our sky, also contain the seeds of our eventual demise? The truth is, we don't really know for sure. The interplay of forces is so complex that the long-term fate of our atmosphere is a profound mystery. It's a silent, slow-motion drama playing out on a cosmic scale, a reminder that our home, even a hypothetical one, is a fragile thing, and its very existence is a beautiful and tenuous balance. We are living in a world of constant violent change, where the weather is a permanent dramatic expression of our new place in the cosmos. It's a terrifying and beautiful thing, a world forged in the shadow of a giant. With a world plunged into twilight and under the constant assault of cosmic forces, the question of life becomes an urgent, almost poetic one. On our old Earth, the sun was the source of all life. It was the great engine of photosynthesis, the ultimate provider of energy that flowed from plant to herbivore to predator. But in this new reality with the sun, a distant, muted star, that old engine is stalled. The surface of our planet, a frozen and radiation-scorched wasteland, is a place where life as we know it would find no purchase. But life as we've learned is a stubborn and creative thing. It finds a way. And in our new Earth, that way would almost certainly be beneath the ice, a whisper of life in the quiet darkness of the deep. This is where we must turn our gaze inward into the very heart of our planet, to a realm where sunlight has never been and is not needed. This idea touches on a beautiful and somewhat strange scientific concept, chemosynthesis. Where photosynthesis uses sunlight to create energy, chemosynthesis uses chemical energy specifically from inorganic molecules like hydrogen sulfide on our old Earth. This is the process that fuels the incredible ecosystems around deep-sea hydrothermal vents. These vents, often called black smokers, for the dark mineral-rich water they spew, are oases of life in the crushing darkness of the ocean floor. Here, in a world of extreme pressure and boiling hot water, bacteria and archaea thrive, forming the base of a food chain that includes giant tube worms, blind crabs, and a host of other bizarre and wonderful creatures. In our new Earth, the geothermal activity from Jupiter's immense tidal forces would supercharge this process. The ocean floor would be a labyrinth of these vents, a network of fire and life beneath a frozen crust. This would be the true heart of our new world, a subterranean biosphere humming with a silent, unseen energy. The deep ocean, shielded from the radiation and the cold, would be a safe haven. The immense pressure of the water would provide a natural barrier, a heavy blanket that would protect life from the surface's chaos. But this would be an ocean unlike any we've ever seen. The waters themselves, constantly churned and heated by the tidal forces, would be a dynamic and active environment. The currents would be a mix of warm water from the vents and cold water from the frozen surface, creating a kind of slow-motion planet-wide conveyor belt. The creatures that live here would have to adapt to this new reality, developing incredible resilience to pressure and temperature fluctuations. It's a fascinating thought that the very forces that make the surface uninhabitable would also create the perfect conditions for life to flourish beneath it. This brings us to a peculiar scientific oddity, one that speaks to the unexpected ways life can exist. The tardigrade, or water bear, is a microscopic animal, known for its incredible ability to survive in extreme environments. They can be frozen, boiled, irradiated, and even exposed to the vacuum of space, and they will still survive. They are, in a sense, the ultimate survivors. In our new hostile Earth, life might have to adopt similar strategies. The organisms that live beneath the ice would be masters of resilience, creatures that have evolved to withstand the most incredible pressures and temperatures. They would be a testament to life's fundamental, almost defiant will to exist. Their story would not be one of struggle against the elements, but one of a quiet, patient adaptation, a slow and silent symphony of survival. The mystery in all of this is what form this life would ultimately take. We can imagine the black smokers and the tube worms. But what about the life that is yet to emerge? The immense energy from the tidal forces could be a kind of cosmic evolutionary pressure cooker, a place where new, unimagined forms of life could arise. What if life in this new reality doesn't need a sun at all? What if it evolves to use the energy from Jupiter's intense magnetic field or the geothermal heat from our planet's core? The truth is, we don't really know for sure. The possibilities are as vast as the deep ocean itself. It's a question that reminds us of the beautiful, unknowable creativity of the universe. Life, it seems, is not just a single fragile thread. It is a woven tapestry, a complex and intricate pattern that can be remade, restitched, and reimagined in the face of impossible odds. So we find ourselves peering into this new dark world and finding not a lifeless void, but a whisper of life. A world where the surface is a silent, frozen tomb, but the deep ocean is a vibrant, bustling city. It is a world where the sun, our old friend, is a distant memory, and the new source of life is the violent, powerful presence of a gas giant. It's a world that forces us to redefine our very notion of what it means to be alive, and a world that reminds us that life's greatest strength is not its dependence on a single star, but its ability to adapt, to change, to find a way to thrive in the quiet darkness. It's a beautiful thought, a whisper of hope in the heart of a cosmic storm. Above the frozen oceans and the simmering geothermally active depths, a new constant would dominate our sky. On our old Earth, we had the moon and the sun and the occasional passing comet or meteor shower. But on this new world, one single celestial body would be our permanent, terrifying, yet beautiful fixture, the Great Red Spot. This is not just a storm. It is a monument to the scale and power of our new celestial master. The Great Red Spot is a high-pressure storm, a vortex of swirling gas larger than our entire planet. It has been raging for centuries, a testament to the chaotic and energetic nature of Jupiter's atmosphere. If you were to stand on our new Earth and look up, this great crimson eye would be a constant, unblinking presence in the sky. It would be a feature so immense and so permanent that it would become a part of our new reality, a cosmic compass, and a source of both fear and awe. The science behind the Great Red Spot is a fascinating and ongoing puzzle. We know it's a high-pressure anticyclonic storm, which means the winds are swirling in a direction opposite to a cyclone. But what drives it, and why has it lasted so long? This is where we touch on a core scientific concept: fluid dynamics. The atmosphere of Jupiter is a vast ocean of gas, a turbulent sea of hydrogen and helium. The Great Red Spot is a kind of permanent weather system, a stable eddy in this chaotic flow. It's an example of a soliton, a self-reinforcing wave or vortex that can maintain its shape and speed over long distances and for long periods of time. The sheer scale of Jupiter's atmosphere means that the storm has a continuous supply of energy, and its immense size means it can resist being broken apart by the smaller storms around it. It's a kind of cosmic paradox, a storm of unimaginable violence that is also a symbol of stability, a chaotic maelstrom that has remained unchanged for centuries. The presence of the Great Red Spot in our sky would have a profound effect on the culture and psychology of any sentient beings who might evolve on this new Earth. It would be a kind of cosmic clock, a permanent celestial body that would change our very understanding of time and motion. The slow, stately rotation of Jupiter would mean the Great Red Spot would drift across our sky in a predictable, majestic arc. It would be a kind of calendar, a way to mark the passage of time, not by the seasons or the sun, but by the movement of a great celestial storm. It would be a constant visible reminder of our place in the cosmic hierarchy, a reminder that we are just a tiny fragile speck of blue and white in the shadow of a colossal turbulent world. This brings us to a peculiar and somewhat unsettling scientific fact. The Great Red Spot is not the only storm on Jupiter. It is just the most famous. The planet's atmosphere is a constant landscape of smaller storms, swirling vortices, and powerful jet streams. From our new vantage point, we would see not just one storm, but a constantly shifting tapestry of atmospheric violence. The view would be a beautiful and terrifying one, a constant reminder that the universe is a place of immense, unpredictable power. It's a vision that would force us to confront our own fragility and our own insignificance. The Great Red Spot would be a kind of cosmic anchor, a stable point in a sky of constant chaos. The mystery in all of this is what lies beneath the spot. We can only see the swirling gas from our vantage point, but what is happening at the storm's core? Is it a permanent feature of Jupiter's atmosphere, or is it a temporary phenomenon that will one day dissipate? The truth is, we don't really know for sure. The internal workings of a gas giant are a profound mystery, and our understanding of them is still in its infancy. This raises a fascinating philosophical question. Does the universe contain things that are truly permanent, or is everything in a constant state of flux and change? The Great Red Spot seems to defy this notion, a storm that has existed for centuries, a stable point in a chaotic cosmos. It's a question that reminds us of the beautiful, unknowable nature of the universe. And so we find ourselves on a world where the sky is a canvas of immense, swirling gas, and the Great Red Spot is a constant, unblinking eye. It is a world where our very sense of time and place is dictated not by a distant sun, but by a colossal permanent storm. It's a terrifying and beautiful thing, a world that forces us to confront the true scale of the universe and our own small place in it. The Great Red Spot is a kind of cosmic sculpture, a work of art forged in the heart of a giant. It is a reminder that beauty can be found in the most chaotic and violent places, and that even a storm can be a source of wonder and awe. As we orbit our new Lord Jupiter, the view from our world would be unlike anything we could have ever imagined. On our old Earth, we were a solitary world with a single faithful moon. But here we are, just one of many courtiers in a vast celestial kingdom. Jupiter is a planet of moons, a family of more than 90 known satellites, each a world in its own right. From our vantage point, our sky would not be a static canvas with one predictable moon, but a dynamic, ever-changing stage with infinite moons dancing across it. This is a cosmic ballet, a synchronized performance of gravitational forces and orbital mechanics that would give us a sky of constant, breathtaking motion. This new reality introduces a core concept of celestial mechanics orbital resonance. This is when two orbiting bodies exert a regular periodic gravitational influence on each other, often because their orbital periods are a ratio of small integers. For example, Jupiter's moons Io, Europa, and Ganymede are in a 4-to-1 resonance, meaning that for every 4 orbits, Io completes, Europa completes 2, and Ganymede completes 1. This regular gravitational tugging keeps their orbits from becoming perfectly circular and is the primary source of the tidal heating that makes Io so volcanically active. On our new Earth, we would be a part of this complex system, our orbit and our very rhythm of time influenced by the movements of Jupiter's other moons. The sky would be a constant source of wonder with moons of all shapes and sizes, from the great icy sphere of Ganymede to the tiny captured asteroids drifting in and out of view. The presence of so many moons would also have a dramatic effect on our tides. While Jupiter's gravity would be the primary driver, the smaller but still significant gravitational pulls of Ganymede, Europa, and Callisto would create a complex multi-layered tidal system. Our oceans would not just have a high tide and a low tide. They would have multiple high tides and low tides, a kind of harmonic series of tidal bulges that would interact and interfere with each other in unpredictable ways. The result would be a planet with an even more violent and chaotic tidal system than we've already imagined, a world where the sea level could change dramatically, not just over the course of a day, but over the course of an hour. It's a beautiful and terrifying thought that the moon, once a symbol of stability and calm, is now a source of chaos and unpredictability. This brings us to a peculiar scientific oddity, one that speaks to the strange beauty of our new sky. The moon Io is the most volcanically active body in the solar system, but it is not the only one. Triton, one of Neptune's moons, has geysers that spew nitrogen ice into space, and Enceladus, one of Saturn's moons, has geysers that spew water from a subsurface ocean. The universe, it seems, is full of these strange and unexpected phenomena. In our new Earth, we would be a part of this family of active, dynamic moons. Our world, with its tidal heating and constant geological activity, would be a member of a club of celestial bodies that are not just silent, dead rocks in space, but living, breathing worlds with their own unique stories to tell. The mystery in all of this is what happens to our sense of a day and a month. The old rhythms based on the sun and our old moon are gone. In their place is a new, more complex rhythm dictated by Jupiter and its many moons. Would we measure time by the orbits of the great Galilean moons, or by the slow, majestic drift of the great red spot? The truth is, we don't really know for sure. The human mind is a master of adaptation, and we would almost certainly find a way to make sense of this new chaotic celestial clock. This raises a fascinating question: is time a constant universal rhythm? Or is it a local phenomenon, a beat that is dictated by the celestial bodies around us? It's a question that reminds us that our understanding of the universe is deeply shaped by our perspective. And on this new world with a sky of infinite moons, that perspective has been fundamentally and beautifully changed. And so we find ourselves on a world with a sky of infinite moons, a celestial dance of giants and dwarfs. It is a world where our sense of time-space and our place in the cosmos has been completely rewritten. We are no longer a solitary dancer, but a part of a grand cosmic ballet, a world in a constant state of motion and change. It's a terrifying and beautiful thing, a world that forces us to confront the true scale and complexity of the universe. The sky is no longer a silent, static canvas. It is a living, breathing work of art, a masterpiece of orbital mechanics and gravitational forces. In this new celestial dance, the very rhythm of time would be fundamentally altered, giving us a long day and a short year. On our old Earth, a day was a tidy 24 hours, and a year was a neat 365.25 days. These were the constants that structured our lives, the natural metronome that set the pace of our existence. But in our new reality, those beats are gone, replaced by a strange new cadence, dictated by the gravitational pull of Jupiter. Our planet's rotation, as we discussed, would be slowing down, tidally locked in a slow, majestic pirouette with our new master. This would make the length of our day, the time it takes for our planet to spin on its axis, a much longer affair. We're talking about a day that could last weeks or even months in our old reckoning. Imagine a world where the sun, a distant pinprick of light, rises and sets over an agonizingly slow period, where the passage of time is a drawn-out, almost meditative experience. This new longer day would be a direct consequence of a core scientific concept, conservation, of angular momentum. Angular momentum is a measure of the amount of rotation an object has. The Earth in its old orbit had a certain amount of angular momentum. But now, as Jupiter's gravity pulls on us, it's not just a simple tug. It's a transfer of energy. Jupiter's immense tidal forces are acting as a brake on our rotation, stealing a tiny amount of our angular momentum and adding it to Jupiter's. This slow, continuous drain of energy is what would cause our planet to slow down. It's a subtle and slow process, but over vast timescales, it would completely reshape our day. The old familiar rhythm of night and day, of sunrise and sunset, would be a distant memory replaced by a new, more languid beat. But while our day is stretching out our year, the time it takes for us to orbit the sun would be dramatically shortened. We are no longer in our comfortable distant orbit. We are now a satellite of Jupiter, which itself orbits the sun once every 11.86 Earth years. This means that our new year would be tied to Jupiter's year, and we would be experiencing a much faster passage of seasons. We would be a world with long drawn-out days and a rapid and almost frantic procession of years. It's a strange and beautiful paradox, a world where time seems to slow down and speed up all at once. This would have a profound effect on the psychology of any beings that might evolve on this new world. Our old sense of a year and a time of renewal and change would be replaced by a more rapid, almost fleeting rhythm. This brings us to a peculiar scientific oddity, one that speaks to the strange nature of time itself. The twin paradox. A thought experiment in Einstein's theory of special relativity shows that time can pass at different rates for different observers. If one twin stays on Earth while the other travels at a high speed through space and then returns, the traveling twin will have aged less. In our new reality, the very rhythm of our planet has changed. We are no longer in a stable, predictable system. We are in a dynamic, rapidly changing one. Our new strange sense of time would be a constant physical reality, a reminder that time is not a constant, but a variable, a fluid that can be stretched and compressed by the forces of the universe. The mystery in all of this is what happens to our understanding of history and memory. If a day lasts for what we used to call a month, how would we tell stories? How would we remember the past? Would we use the slow, majestic drift of the Great Red Spot as our clock, or the rapid, fleeting passage of our new year? The truth is, we don't really know for sure. The human mind is a master of adaptation, but a change of this magnitude would be a profound challenge. This raises a fascinating philosophical question. Is memory a product of time, or is time a product of our memory? It's a question that reminds us that our understanding of the universe is deeply shaped by our perspective, and on this new world with a long day and a short year, that perspective has been fundamentally and beautifully changed, and so we find ourselves on a world with a long day and a short year, a world where the very rhythm of time has been completely rewritten. We are a planet in a state of temporal flux, a world where our sense of history and our place in the cosmos has been completely reshaped. It's a terrifying and beautiful thing, a world that forces us to confront the true nature of time itself. The old familiar rhythms of our world are gone, replaced by a new, more powerful beat. It's a world in the process of being born again, a world shaped by the tidal breath of a giant. Our new home, nestled within the vast, swirling kingdom of Jupiter, would be a world constantly bathed in a beautiful and terrifying celestial phenomenon. We're talking about the planet's immense magnetic field, a force so powerful it would become a part of our new reality. A journey through the magnetosphere would be a journey into a world of cosmic radiation and ethereal light, a place where the very fabric of our reality is shaped by invisible electromagnetic forces. This is where we delve into the science of magnetism, a core concept of physics. We often think of magnets as simple objects, but a magnetic field is a powerful force that can guide and accelerate charged particles. Jupiter's magnetic field is 1,000 times stronger than our own, a vast, complex web of charged particles that extends millions of kilometers into space. Our planet, now a tiny boat sailing in this immense invisible ocean, would be constantly bombarded by a stream of high-energy particles from the solar wind and from Jupiter's volcanic moon, Europa. This constant bombardment is what creates the permanent aurora we discussed earlier, a shimmering iridescent veil of light that would cover our entire sky. But this beauty comes with a price. The sheer intensity of the radiation within Jupiter's magnetosphere would make the surface of our planet uninhabitable for most life as we know it. We're talking about a level of radiation so intense that it would sterilize the surface, making it a barren and desolate wasteland. This is a fascinating scientific fact. The radiation belts around Jupiter are so strong that they can damage the electronics on a passing spacecraft. Our planet, as it orbits, would be a constant recipient of this cosmic assault, a world that is at once shielded and exposed. The magnetosphere, in a sense, is a paradoxical force. It creates a beautiful light show in our sky, but it also contains a deadly invisible river of radiation. The journey through the magnetosphere would be a journey into a world of complex and somewhat chaotic physics. Jupiter's magnetic field is not a simple static force. It's a dynamic, rapidly changing system with its own currents, waves, and storms of charged particles. Our planet, as it orbits, would be constantly moving through different parts of this field, experiencing fluctuations in radiation levels and magnetic forces. This would have a profound effect on our planet's own magnetic field, creating a complex interplay of forces that would be almost impossible to predict. It's a kind of cosmic dance of electromagnetism, a beautiful and terrifying ballet of invisible forces. This brings us to a peculiar scientific oddity, one that speaks to the strange beauty of our new home. Jupiter's moon Io, with its intense volcanic activity, is a constant source of material for Jupiter's magnetosphere. The volcanoes on Io spew sulfur, oxygen, and other gases into space, and these particles are then ionized and captured by Jupiter's magnetic field, forming a kind of donut-shaped ring of plasma around the planet. Our new Earth, as it orbits, would be moving through this plasma ring, a cosmic river of charged particles that would constantly be flowing past us. It's a fascinating and beautiful thought that a volcanic moon on the other side of our new home could have such a profound and constant effect on our own planet. The mystery in all of this is what happens to our planet's own magnetic field. Our planet's molten iron core is what gives us our protective magnetic field. But with this constant immense tidal stress, would the core's churning motion be affected? Could this new tidal reality slow the core's rotation, weakening our magnetic field? Or could the tidal friction heat the core even more, creating a more powerful field? The truth is, we don't really know for sure. The internal workings of a planet are a complex, mysterious system. It's a silent, hidden drama, a slow dance of metal and heat that we can only glimpse from afar. This raises a fascinating philosophical question. Does a planet's fate sealed by its initial conditions, or can a new powerful influence fundamentally change its destiny? It's a question that reminds us of the beautiful, unknowable chaos of the universe. And so we find ourselves on a world constantly in motion, a planet that is not just a rock in space, but a participant in a grand cosmic ballet of electromagnetism. We are a world that is at once shielded and exposed, a world that is shaped by the invisible powerful forces of a giant. The journey through the magnetosphere is a journey into a world of cosmic wonder and terror, a place where the very fabric of our reality has been completely rewritten. It's a beautiful and terrifying thing, a world that forces us to confront the true scale and complexity of the universe. The constant journey through Jupiter's magnetosphere and the unyielding tidal forces would have a subtle yet profound long-term effect on our planet. We're talking about the atmosphere's gentle escape, a slow, inexorable process that would subtly strip away the protective blanket that makes our planet habitable. On our old Earth, our atmosphere was a stable, self-contained system, a delicate balance of gases held in place by our gravity. But in this new reality, that balance is shattered. Jupiter's gravity and the constant solar winds would be a persistent, powerful force, a cosmic sandblaster that would slowly, inexorably erode our atmosphere away. This is where we touch upon a core scientific concept: atmospheric escape. This is the process by which a planet's atmospheric gases leave the atmosphere over time. On Earth, this happens at a very slow, almost imperceptible rate. But on our new Earth, this process would be supercharged, turning a slow drip into a steady stream. This process is driven by two main factors. First, the immense tidal forces from Jupiter would be constantly pulling on our atmosphere, creating a kind of slow-motion atmospheric tide that would be constantly stretched and pulled. While the majority of the air would be held in place by our own gravity, a tiny, almost immeasurable amount would be lost with each tidal pulse. Over millions of years, this would add up to a significant loss of our atmospheric volume. Second, the constant bombardment of high-energy particles from Jupiter's magnetosphere would be a powerful force for atmospheric escape. When these particles hit our upper atmosphere, they would impart so much energy to the gas molecules that they would achieve escape velocity flying off into space. This is a kind of cosmic sandblasting, a constant low-level assault that would slowly but surely thin out our atmosphere. This brings us to a peculiar scientific oddity, one that speaks to the strange beauty of our new home. The moon Ganymede. Jupiter's largest moon has a very thin, tenuous atmosphere of oxygen. This atmosphere is not a product of life, but a result of the constant bombardment of charged particles from Jupiter's magnetosphere hitting the moon's icy surface. The particles break the water ice apart into hydrogen and oxygen, and while the hydrogen is too light to be held by Ganymede's weak gravity, the oxygen remains, creating a kind of ghost atmosphere. In our new Earth, a similar process would be at play, but on a much larger scale. Our atmosphere would be a constant battle between creation and destruction, a delicate balance between the gases that are being created by volcanic activity and the gases that are being stripped away by Jupiter's powerful forces. The mystery in all of this is what happens to our atmosphere over the long term. Does it eventually disappear, leaving us a cold, lifeless rock? Or does it reach a new fragile equilibrium, a new kind of atmosphere that is perfectly adapted to our new reality? The truth is, we don't really know for sure. The interplay of forces is so complex that the long-term fate of our atmosphere is a profound mystery. It's a silent, slow-motion drama playing out on a cosmic scale, a reminder that our home, even a hypothetical one, is a fragile thing, and its very existence is a beautiful and tenuous balance. This raises a fascinating philosophical question. Does a planet's destiny sealed by its initial conditions, or can a new powerful influence fundamentally change its destiny? It's a question that reminds us of the beautiful, unknowable chaos of the universe. And so we find ourselves on a world with a slowly escaping atmosphere, a planet that is not just a rock in space, but a participant in a grand cosmic ballet of creation and destruction. We are a world that is constantly being reshaped, a planet that is slowly, gently being stripped of its protective blanket. It's a terrifying and beautiful thing, a world that forces us to confront the true scale and complexity of the universe. The atmosphere, once a symbol of our stable and comfortable existence, is now a testament to our new fragile reality. In this world of perpetual twilight and planetary chaos, the silent symphony of adaptation would begin to play. We've discussed the physics and geology of our new home, but what about the biology? On our old Earth, life was a product of sunlight, of a predictable cycle of seasons, and of a relatively stable environment. But in this new reality, those old rules are gone. The life that survives and the life that emerges would be a testament to the incredible resilience and creativity of evolution. We're talking about a slow, deliberate reshaping of life, from the microscopic to the macroscopic, a process of evolution that is shaped by new pressures and new opportunities. It's a beautiful and profound thought that even in the face of a cataclysmic shift, life finds a way to write a new song. This process would be a function of a core scientific concept, natural selection. The organisms that are best adapted to this new hostile environment would be the ones to survive and reproduce. We would see a dramatic shift in the biosphere, a kind of planetary culling that would leave only the most resilient, The plants on the surface, starved of sunlight, would die off. But in the deep oceans, where geothermal energy is abundant, a new kind of flora and fauna would emerge. We're talking about bioluminescent plants and animals creatures that have evolved to create their own light in a world of perpetual darkness. Imagine a forest of glowing fungi, a silent, shimmering world of bioluminescent life that lights the ocean floor. Or imagine a deep-sea creature that has evolved to use the energy from Jupiter's magnetic field, a kind of biological antenna that can harvest cosmic energy. This is not science fiction. It is the natural consequence of a new powerful set of environmental pressures. The animals that survive on the surface, if any, would have to adapt in incredible ways. We're talking about creatures that have evolved to withstand extreme cold and radiation, animals with thick insulating coats of fur and enhanced senses that allow them to hunt in the perpetual twilight. The old predators and prey would be replaced by new ones, a silent drama of survival playing out in a world of constant darkness. This brings us to a peculiar scientific oddity, one that speaks to the strange beauty of adaptation. The axolotl, a type of salamander, has the incredible ability to regenerate lost limbs, even parts of its brain. In a world of constant geological chaos and unpredictable violence, the ability to heal and regenerate would be a key to survival. The animals of our new Earth might evolve similar incredible abilities, a testament to the fact that evolution is not just about survival, but about resilience and renewal. The mystery in all of this is what happens to consciousness. If a new sentient species were to evolve on this world, what would their art, their music, their philosophy look like? Would their sense of time be shaped by the slow, majestic drift of the Great Red Spot, or by the rapid fleeting passage of their new year? The truth is, we don't really know for sure. The human mind is a product of our environment, and a change of this magnitude would be a profound challenge. This raises a fascinating philosophical question. Is consciousness a product of our environment, or is it an intrinsic property of the universe? It's a question that reminds us that our understanding of the universe is deeply shaped by our perspective. And on this new world, with a slow, silent symphony of adaptation, that perspective has been fundamentally and beautifully changed. And so we find ourselves on a world where the biosphere has been completely rewritten, a planet where the silent symphony of adaptation is playing out in the dark. We are a world that is constantly being reshaped, a planet where the old rules of life are gone, replaced by a new, more powerful beat. It's a terrifying and beautiful thing, a world that forces us to confront the true scale and complexity of the universe. The life that emerges from this new reality would be a testament to the incredible resilience and creativity of evolution, a silent, beautiful song in the heart of a cosmic storm. As we've settled into our new reality, the most beautiful and terrifying constant in our sky would be the aurora's whispering veil. On our old Earth, the aurora borealis was a rare, majestic spectacle, a shimmering light show that happened only in the high latitudes. But in this new world, with our planet nestled deep within Jupiter's immense magnetosphere, the aurora would be a permanent fixture, a constant shimmering curtain of light that would paint the darkness with ethereal color. This is not just a light show. It is a direct and constant expression of the raw, untamed power of our new celestial parent. It would be a permanent, breathtaking reminder of our place in the cosmic hierarchy. This beautiful phenomenon is a product of a core scientific concept, the interaction of charged particles with atmospheric gases. Jupiter's magnetosphere, a vast invisible ocean of plasma and high-energy particles, is a kind of cosmic blender. It traps and accelerates particles from the solar wind and from Jupiter's volcanic moon, Io, creating immense radiation belts. Our new Earth, as it orbits, would be constantly moving through this maelstrom with charged particles hitting our upper atmosphere. When these particles collide with the gases in our atmosphere, oxygen, nitrogen, and others, they excite the gas atoms, causing them to glow. Oxygen, for example, glows with a beautiful green or red light, while nitrogen glows with a soft, ethereal blue. The result would be a planet-wide aurora, a shimmering multicolored veil that would cover our entire sky, a permanent light show that would turn the darkness into a canvas of living color. The constant presence of the aurora would have a profound effect on the culture and mythology of any sentient beings who might evolve on this new Earth. On our old Earth, we had myths about the sun, the moon, and the stars. We had stories of gods and goddesses who lived in the sky. But on this new Earth, the sky would be a constant active presence. The aurora would be a kind of living entity, a whispering veil that would be a source of both wonder and fear. The colors and shapes of the aurora would be a constant source of inspiration for art, for music, for poetry. It would be a kind of cosmic language, a silent, beautiful conversation between our planet and its new master. The aurora would be a kind of visual calendar, a way to mark the passage of time, not by the sun or the moon, but by the subtle shifts in the color and intensity of the light. This brings us to a peculiar scientific oddity, one that speaks to the strange beauty of our new home. Jupiter's moon. Ganymede, the largest moon in the solar system, has its own magnetic field. This means that as it orbits within Jupiter's magnetosphere, it creates its own auroral light show. This is a fascinating fact, that a moon can have its own magnetic field, and it speaks to the incredible complexity and dynamism of the Jovian system. In our new reality, our planet would also be a source of its own aurora, a kind of smaller, more localized light show that would interact with the larger planet-wide veil from Jupiter. It would be a kind of celestial dance of light, a beautiful and complex interplay of magnetic fields and charged particles. The mystery in all of this is what happens to our perception of a sky. On our old Earth, the sky was a kind of vast, silent canvas, a background for the drama of the sun and the moon. But on this new Earth, the sky is a living, breathing entity, a constant source of light and motion. How would this constant immersive experience affect our minds? Would we become accustomed to the constant light, or would it be a permanent source of wonder and awe? The truth is, we don't really know for sure. The human mind is a master of adaptation, but a change of this magnitude would be a profound challenge. This raises a fascinating philosophical question. Is beauty a product of rarity? Or can we find wonder in a world of constant, overwhelming beauty? It's a question that reminds us that our understanding of the universe is deeply shaped by our perspective. And on this new world, with the aurora's whispering veil, that perspective has been fundamentally and beautifully changed. In this new world, with its violent tides and perpetual twilight, the very ground beneath our feet would be a record of our cataclysmic journey. The geological record of our old Earth is a silent, unwritten history of continents, drifting mountains, rising, and oceans forming. But in this new reality, the echoes from the dawn of time would be a much louder, more violent story. The layers of rock and ice would not be a slow, gradual accumulation of history, but a dramatic, punctuated record of immense change. We are talking about a world where the very geology is a testament to the immense power of Jupiter's gravitational embrace. This new geological history would be a function of a core scientific concept, stratigraphy. This is the study of rock layers and layering, and it is the primary way geologists read the history of our planet. On our old Earth, a layer of rock might represent millions of years of slow, gradual change. But on our new Earth, a layer of rock could represent a single violent tidal event. The constant, immense tidal forces from Jupiter would be a primary driver of erosion and deposition, creating vast new sedimentary basins and tearing away at old landmasses. The result would be a geological record that is a chaotic mix of violent cataclysms and periods of quiet, frozen stasis. The layers of rock would tell a story of a world in a constant state of flux, a planet that is being constantly remade by a powerful unseen hand. This new geological reality would also affect the very composition of our planet's crust. The immense tidal friction would create a constant flow of magma and volcanic activity, bringing new material from the mantle to the surface. This would be a kind of geological recycling, a process that would constantly be creating new land and destroying old. We would be living on a world in a perpetual state of geological rebirth, a planet where the ground beneath our feet is never truly still. This brings us to a peculiar scientific oddity, one that speaks to the strange beauty of our new home. The moon Ganymede. Jupiter's largest moon has a surface that is a strange patchwork of old, dark, cratered terrain and younger, brighter grooved terrain. This is believed to be the result of a process called cryovolcanism, where water ice, rather than molten rock, erupts from the moon's interior. In our new Earth, with its immense tidal heating, we could see a similar process with water ice and molten rock mixing in a chaotic, beautiful dance of creation and destruction. The mystery in all of this is what happens to the fossils. In our old Earth, the fossil record is a quiet, gradual story of life evolving over millions of years. But in this new reality, with its violent, chaotic geology, would the fossil record be preserved? Would the immense tidal forces and constant volcanic activity destroy the fragile remains of life? Or would the sudden violent burial of a coastal plain in a tidal wave create a new dramatic kind of fossil record? A snapshot of a moment in time frozen in rock. The truth is, we don't really know for sure. The interplay of forces is so complex that the long-term fate of the fossil record is a profound mystery. It's a silent, slow-motion drama playing out on a cosmic scale, a reminder that our home, even a hypothetical one, is a fragile thing, and its very existence is a beautiful and tenuous balance. This raises a fascinating philosophical question. Is history a matter of written record, or is it a matter of a silent, unwritten story? A story that is told in the layers of rock beneath our feet. It's a question that reminds us that our understanding of the universe is deeply shaped by our perspective, and so we find ourselves on a world where the geological record is a loud, dramatic story of immense change. The echoes from the dawn of time are not a silent whisper, but a loud resonating hum from the molten heart of our planet. We are a world that is constantly being remade, a planet where the old familiar story of our planet has been completely rewritten. It's a terrifying and beautiful thing, a world that forces us to confront the true scale and complexity of the universe. The rocks beneath our feet are not just silent dead things. They are a living, breathing testament to our new fragile reality. In this strange new world, where the rhythms of time and the very fabric of our reality have been rewritten, the most profound changes would be to the psychological landscape of a new home. On our old Earth, our minds were shaped by a predictable cycle of day and night, by a calendar of seasons, and by the comforting stability of a single faithful moon. But in this new reality, that old cognitive framework is gone. The human experience, or the experience of any sentient being that might evolve here, would be fundamentally reshaped. We would be living in a world of perpetual twilight, with a sky dominated by a colossal banded giant, a world of constant chaos and unpredictability. This is where we touch on a core concept of psychology, the human need for order and predictability. Our minds are built to find patterns, to create narratives, to make sense of the world around us. But in this new world, with its long drawn-out days and its chaotic multi-moon sky, those old patterns would be shattered. We would have to create a new way of understanding our place in the cosmos, a new kind of mental map for a world that defies all our old rules. The constant presence of Jupiter in the sky would be a source of both wonder and terror. On our old Earth, we had the sun, a symbol of life and warmth, and the moon, a symbol of mystery and romance. But on this new Earth, Jupiter would be a kind of divine, all-powerful presence, a constant reminder of our smallness and our fragility. The Great Red Spot, a terrifying and beautiful storm, would be a kind of cosmic eye, a constant, unblinking witness to our every action. This would have a profound effect on our mythology and our religion. The old gods of the sun and the moon would be replaced by a new, more powerful deity, a god of chaos and power, a god of the sky. This brings us to a peculiar scientific oddity, one that speaks to the strange beauty of the human mind. The placebo effect, where a person's belief in a treatment can lead to a real physical improvement, is a testament to the incredible power of our minds to shape our reality. In our new world, a new belief system, a new mythology would emerge, a new way of making sense of a world that is at once terrifying and beautiful. The mystery in all of this is what happens to our sense of identity and community. On our old Earth, our communities were built around a shared sense of time and place. We had festivals to celebrate the harvest holidays, to mark the solstice, and stories that were passed down from generation to generation. But in this new reality, with its long chaotic days and its rapid fleeting years, those old rhythms would be gone. Would a new sense of community emerge, a community built around the shared experience of living under the shadow of a giant? Or would we become a species of solitary introspective beings, each of us trying to make sense of this strange new world on our own? The truth is, we don't really know for sure. The human mind is a master of adaptation, but a change of this magnitude would be a profound challenge. This raises a fascinating philosophical question. Is a community a product of shared time and place, or is it a product of shared experience? It's a question that reminds us that our understanding of the universe is deeply shaped by our perspective. And on this new world, with its strange new psychological landscape, that perspective has been fundamentally and beautifully changed. And so we find ourselves on a world where the very landscape of our minds has been completely rewritten. We are a species in a state of psychological flux, a world where our old ways of making sense of the world are gone. It's a terrifying and beautiful thing, a world that forces us to confront the true nature of our own consciousness. The psychological landscape of our new home is a testament to our incredible resilience and our ability to find meaning and beauty in a world that defies all our old rules. We are a species of storytellers, and in this new world, we would have to learn how to tell a new story, a story of a long day and a short year, a story of a sky of infinite moons, a story of a world in the shadow of a giant. We have traveled so far not just through the cosmos, but through the landscape of our own imagination. We have seen a world of perpetual twilight, of violent tides, and a sky of infinite moons. We have contemplated a planet that is at once a living, breathing entity and a fragile cosmic toy. Now, in this final part of our journey, we will bring all the threads together, contemplating the beauty and the terror of this hypothetical world, and gently, slowly guide our minds back to the quiet reality of our own room. We have seen a world forged in the shadow of a giant, a world where the old rhythms are gone and a new, more powerful beat has emerged. It's a testament to the fact that the universe is a place of constant change, a place where the old can be destroyed and the new can emerge beautiful and terrifying in equal measure. This final contemplation is a function of a core scientific concept, the interconnectedness of all things. We started with a simple question. What if the Earth was a moon of Jupiter? And that simple question led us to a complex web of interconnected ideas. The gravity of Jupiter affected our tides, which affected our geology, which affected our atmosphere, which affected our weather, which affected our biology, which affected our psychology. Every single part of this hypothetical world was a function of every other part. This is not just a scientific truth. It is a profound philosophical truth. The universe is not a collection of isolated objects. It is a single, vast, interconnected system. A change in one part of the system, no matter how small, can have a profound effect on every other part. This is a beautiful and humbling thought, a reminder that we are not isolated beings, but a part of a single vast cosmic symphony, This brings us to a peculiar scientific oddity, one that speaks to the strange beauty of our new home. The cosmic microwave background, the faint pervasive afterglow of the Big Bang, is a silent, constant presence in the universe. It is a reminder that the universe in its earliest moments was a place of incredible heat and energy, and that the beautiful cold and empty space we see today is a product of billions of years of cooling and expansion. In our new reality, the background noise of our universe would be Jupiter. It would be a constant, powerful presence, a silent, unblinking witness to our every action. It would be a reminder that our home, even a hypothetical one, is a part of a much larger, more powerful system. A system that is at once beautiful and terrifying. The mystery in all of this is the ultimate fate of our planet. Would it eventually be torn apart by Jupiter's immense tidal forces, a kind of cosmic divorce that would leave our planet as a ring of debris around the giant? Or would it find a new fragile equilibrium? A new way of existing in this strange new reality? The truth is, we don't really know for sure. The interplay of forces is so complex that the long-term fate of our planet is a profound mystery. It's a silent, slow-motion drama playing out on a cosmic scale, a reminder that our home, even a hypothetical one, is a fragile thing, and its very existence is a beautiful and tenuous balance. This raises a fascinating philosophical question. Is a planet's fate sealed by its initial conditions? Or can a new powerful influence fundamentally change its destiny? It's a question that reminds us of the beautiful, unknowable chaos of the universe. And so we find ourselves at the end of our journey, a journey that has taken us to the very edge of our imagination. We have seen a world of perpetual twilight and planetary chaos, a world that is a testament to the incredible power and beauty of the universe. We have contemplated a world that is at once terrifying and beautiful, a world that forces us to confront the true nature of our own existence. The quiet darkness of our room, the soft blanket, the gentle hum of the fan, they are not a symbol of a lack of wonder. They are a symbol of a different kind of wonder, a wonder that is born of a quiet, gentle reality. The journey we took was a journey into the heart of a cosmic storm, a journey into the heart of a planet that is at once familiar and utterly alien. We have returned, but we are not the same. We have seen the universe in a different light, and in that light, we have seen ourselves in a different light as well. The journey we took tonight was a journey into the heart of a cosmic storm, a journey that has now come to a close. But as we slowly, gently bring our minds back to the moment, I'd like to ask one last time, where is the place you're staying now? The time in that place at this very moment. How is it flowing? I'd like you to take a deep, slow breath and feel the gentle weight of your body. The soft blanket, the gentle whisper of the air in the room, the chaos and the wonder of our journey. They are now a part of you, a part of the vast tapestry of your own mind. They are a gentle memory, a soft echo on the wind. Let them fade gently into the quiet darkness. I'd like you to let go of the day's worries, the day's anxieties, the day's chaos. Let them gently brush past you like a soft breeze. Allow yourself to sink into the gentle embrace of the night. Sleep well, my companion, wherever and whenever you are. May your dreams be filled with quiet wonder and soft light.